Continuing on here in section 7.5, example 4 is going to be converting from radical form to exponential form. Exponential has the exponent. So here, that's what we're going to try and write them in, is an exponential form with an exponent. So I take my radicand as my base. My numerator is already raised up. It's higher, so it goes in my numerator, which is higher. My denominator, here I have a fifth root, so I write it as 3/5. Okay, my index becomes my denominator. Same idea here in B, but before I reduce it, or before I switch to exponential form, I'm going to reduce it. 9 times 3 and 3 times 3. So what I have here is the cubed root. Instead of 27, I'm going to write 3 times 3 times 3. I didn't change my d though, so that's still times d to the 5th power. I'm looking here for groups of 3 things. And I have 3 3s here. That comes out as a single group of 3s. So I have 3 times the cubed root left inside d to the 5th power. And now I needed an exponential form, so I need it with an exponent. I take my radicand as my base. My 5 is already raised up as an exponent, so I put it up in my numerator. I say the cubed root, so I put that over 3. My index becomes the denominator of my exponential form. Now we're going to rewrite each radical in exponential form, which means we need an exponent. I take my base from my radicand. I take my numerator from my exponent, and I take my denominator from my index. The 2 is already raised up, so it goes on top. Make sure when you write these that it's an exponent here, not multiplying by 2/3. So make sure that's raised up and we can tell the difference. Same idea here. My 12 is still just times this expression. And so I'm going to rewrite that as an exponential form. I'm going to take the radicand as my base. It's already raised to the 4th power, so 4 is higher. And the 3 from my index becomes my denominator of that exponent. So I have 12 times x to the 4/3 power. On C here, I'm going to rewrite this just a little bit. I'm going to move this exponent out. You don't have to. I personally just like to work with it last. I think it's easier to make things smaller before we make things bigger than if we make them bigger before we make them smaller, which sounds kind of weird. But if we do it the other way, we have to take 4 to the 5th power and then try and break it down into its pieces. When I'd rather break it down into its pieces, it's just a 4. So here what we have is the square root. 4 is just 2 times 2 times y. And then again, we still need our exponent there. So the whole thing is raised to the 5th power. When there's not an index here, guys, it's a 2. Okay, we know it's a square root when we don't see one, which means 2. I'm going to look for groups of 2 things. Here I have groups of 2. They just happen to be 2s, so they go inside here. Out of my radical, but still inside my parentheses, the y that's left stays inside. Keep in mind, this entire thing is still being taken to the 5th power. Now, I have a product to a power. All that means, guys, is that I have something multiplied inside my parentheses. All I have is multiplication, and it's being raised to an exponent. So I can take that exponent to each of my factors. 2 to the 5th power, y to the 5th power. Here, 2 to the 5th power is 32. And I'm going to switch from radical form to exponential form because that's what we're trying to do with these problems here. So I'm going to keep my radicand as my base. My exponent becomes my numerator. And my index, which is a 2 here, becomes my denominator. And I get 32 times y to the 5/2 power. In D here, same idea. I'm going to break down my number part. 256 is 16 times 16, but if you're not sure, we know it's even, so we can take out a 2 if nothing else. So I took 256 divided by 2 and got 128. I'm going to divide it by 2 and get 64. And 64 is a little bit more common. We're a little bit more comfortable with that. 8 times 8, for example. So we still broke down 256, even though off the top of our head, we didn't know that it was 16 times 16. That's okay. Break down the number based off the things that you know. So if it's even, for example, we know we can try dividing it by 2. If it's divisible by 3, take out a 3, and eventually you're going to get to smaller pieces that are a little bit easier to break down. So here I'm going to rewrite this as the fourth root. Instead of 256, I'm going to rewrite it as 1, 2, 3, 4, 5, 6, 7, 8 2's multiplied together. And don't forget that we still have a to the 8th power. I'm looking for groups of 4 things here. I have a group of 2's that come out as a 2. I have another group of 4 2's that I can bring out as a 2. And since all we're doing inside is multiplying, that's what we're going to do with our groups of 2's that we bring out as well. Here I have 4 on the outside times the fourth root of a to the 8th power. Now we're trying to write this in exponential form. So I'm going to take my radicand as my base. My numerator comes from my exponent. And my denominator of that exponential form comes from the index. Last thing I'm going to do here is I know that 8 divided by 4 is 2. So I'm just going to simplify there. And I get 4 times a squared. In example 4, we can estimate the metabolic rate of living organisms based on body mass using Kleber's law. The formula R equals 73.3 times the fourth root of m cubed relates metabolic rate R measured in calories per day to body mass m measured in kilograms. What is the metabolic rate of a dog with a body mass of 18? So we're looking for what is the metabolic rate. And here it tells me that metabolic rate is R. So we are looking for R. We don't have to solve this at all. It's already solved for R. So we're looking for R based off a body mass of 18 kilograms. And here it says body mass is M measured in kilograms. So that's a helpful clue that we're just going to plug 18 in for M. I'm going to take 73.3 times the fourth root of 18 cubed. The hardest part of this problem, guys, is just typing it in our calculator. So when we go to type this in our calculator, we're going to take 73.3 times, okay, right here. We type in 4. Then we use the second key on the top left, as long as you have a TI like the one on my wall. Then we're going to press the exponent key. And when we do this second exponent key, it should give us 4 and then this little symbol. And that just tells us that it's the fourth root. So the square root doesn't have the little x there. The x just tells us that we're filling in with whatever numbers beforehand. So here we have the fourth root. Then we'll type in 18 raised to the third power. When you do that, we should get approximately 640.6, 0.55 something, 0.6, and that's labeled in calories per day. So again, the biggest part here is just typing it in your calculator. And if you're still not getting that, let me know and I can help you figure out how to get those typed in. Now, same idea here. Give this a try if you want to. Remember that our formula is R equals 73.3 times the fourth root of m cubed. So body mass is 75 kilograms. We're going to plug that in for m. And we are looking for the rate. What is the rate? Rate is R. So 75 cubed. Again, we're going to take 73.3 times 4. And then to get that fourth root, we have to use the second key and then press this, which again should give us something that looks like that in our calculator. And then we type in 75 raised to the third power. Here, our rate is approximately 1,868 calories, and that's per day. So again, the biggest thing there is making sure we're getting the radical right when we type that in. Real quick recap here. We can use rational exponents to represent radicals. And that's all I have for section 7.5.